Hi everyone, so I am Denis Jannot. I am working at Solo.io, and I'm going to speak about benchmarking. And the reason why I put this kind of provocating title is really that there are so many times you see benchmarks that tries to compare one service mesh with another, and all the time it's they are kind of crazy. Sometimes you see 10 milliseconds latency, or I don't know, really huge differences between one mesh and another. And so what I want to do today is not to compare Istio with anything else. I think that many of you use Istio, so I don't think I need to convince you to use it, right? What I want to do is really to try to replicate live a benchmark that is similar to what you see in the Istio documentation website. So I don't know if you are familiar with this page. And if you want to have some fun, you can look at the results in the past 5 or 6 or 7 years, right? And you will see the numbers are very different. And you could think, okay, they are different because Istio has been evolving so much that is it went from 10 milliseconds to less than 1 millisecond. In reality, it has evolved for sure. It became really faster and faster. But the truth is that the CPU you use for benchmarks is a big difference. If you try to do a benchmark in virtual machines, you will always get multi-milliseconds latency for P99. If you do that bare metal with a CPU that is 10 years old, maybe you will get 1 millisecond. If you do it with something newer, right, you will get a few hundreds of microseconds, right? So it's you cannot really, that's why I think that this type of comparison is always very difficult. So what I try to do here is really more to show you what, with the CPU I'm going to use, what is going to be the baseline, and then what's going to be the cost of sidecars, and what will be the cost of Ambient layer 4 and Ambient layer 7, right? So that you can get confident with it. And the reason why I like to do it live is because, okay, then you can trust it because you see the numbers, and we will start from scratch, and I will share with you the instructions to replicate it. So there is no tweak, there is no special CPU allocation or memory or whatever. It's everything is installed with the default values. Absolutely nothing is tweaked to get better performance or anything like that, okay? So the test environment will look like that. As I said, if you want to get really good numbers, you need to use bare metal servers, right? You cannot get very low latency with virtual machines. Even worse if you use the cloud providers because you don't have any control on the infrastructure itself, right? So the one that are published in the Istio website, they are using a multi-server bare metal with a very strong network. Obviously, I don't have access to that. You could, again, on the service provider, get some bare metal servers, but then you would still have no control on the network between these ones, right? So the only way you can really replicate that is using a bare metal machine and using something like Kind so that you don't really have extra cost for the network between your nodes, right? And what I'm using here also is for people who are familiar, what we use in this standard benchmarking in Istio is something called Fortio, and it became its own project if you want, so you can use it outside of Istio, right? But I said, okay, to really establish trust, it's always even better if I use a benchmarking tool that is not from the Istio community at all, right? So that is just something like K6 from Grafana is something that is, completely independent, so I will use that. I will still use the Fortio backend server because I need a very fast web server that doesn't introduce by itself, latency and things like that. But the client is going to be K6. I will also get the metrics using Prometheus, display that in Grafana, and also using Kiali to just validate, okay, what type of metrics we get and so on. And I will have some preparation steps. What I'm going to do, I'm going to launch the script in a minute, and it's going to take 5 minutes to do all these steps that you see here, right? It's pretty fast. While we will wait for these 5 minutes, I'm going to go through the README that I will share with you that shows these instructions, like the script itself, basically. So I will show you how everything is installed. So you can see there is nothing that is tweaked here, right? It's like a pure standard Istio installation and K6 installation and so on, okay? And then after that, we will do these different tests. So the script will continue to run, and it will do very quick measurements, because obviously we don't have much time, right? But it will be like 2 minutes trying to look at what is the baseline performance with no mesh, nothing. Then 2 minutes of sidecar. Then 2 minutes of sidecar with layer 7 policy applied. Then will be 2 minutes with ambient with just layer 4. And then 2 minutes with layer 4 plus layer 7 in ambient, okay? So even with all these things, we'll probably be able to do that without all this full talk. So we still have time for the Q&A. I mean, if everything works well, because I'm going to use my desktop, which is in Paris, hopefully it's not going to strike. You know, we are very popular for that in France, so let's see. So let me not show you the result right now. So I'm going to start this script here, and I will share with you the QR code so that you get the instruction if you want to run yourself. But while it is running here and deploying the kind cluster behind the scene, maybe I show it here, so if something is going wrong, I can notice it. And so this is the script, and I maybe make it bigger, right? Because you probably cannot read this thing. Is it good here? Yeah, cool. So what it's doing, right? Very simple. It's deploying a kind cluster. Then it's installing the tooling. So it's installing like Prometheus. There are a few options here. I don't know if for people who are familiar with this Prometheus observability, you have this notion of native histogram that are kind of a game changer when you want to get metrics. So there is like this ability to have native histograms with K6, and there is a dashboard that exists also for that. So I just enable these native histograms there. Then I deploy Grafana, and nothing special here. Just telling that I want the data source to be my Prometheus that I deployed before. Then I deploy Istio using Helm. Again, you can see here, I on purpose don't use any value files, right? So that you can see there is nothing like tweaked here. It's like a pure, vanilla Istio installation. So I install it in ambient mode. It doesn't matter because you can be in ambient mode and still use sidecars, right? So you can still measure the sidecars by itself. I install a metric server here, just in case we want to take a look during the demo of, okay, what is the CPU used by zTunnel or by sidecar or by whatever, right? We can do that with this metric server. I install Kiali to be able to just check as well in the graph, who talks to who, what type of metrics do we have. And finally, I install some demo application. I try to make the name like a little bit meaningful. So it means like not in mesh is like I am not in the mesh, as you can guess. In mesh, maybe it's a little bit confusing, but it means sidecar, right? It's the traditional sidecar model. And you see that because you see I have this metadata here that say I want to inject the sidecar. And then you have the in ambient, as you can imagine, it's in ambient. And it has like, the injection disabled, and it has the data plane mode, which is ambient. We can do a get pods at the end just to take a look at it. I also have some clients to make requests. I'm not really going to use this, but if at some point you have a question and you want us to do something together, we can use this. And I think you see behind here, it's like waiting for all this stuff to be ready. And what it's going to do is just updating the services I deployed to use this Fortio image. As I said, I could use another one, but it's just like, it's very quick to respond to GET requests. It doesn't try to do anything fancy. It just tries to do the minimal processing time on the backend. And after this is done, this is checking everything is running, which is happening here. And it's going to start the first test. So the first test is going to be the baseline. And you have many different ways to configure K6 to do benchmarks. The one I use here is called a constant arrival rate. So what I want is that I want to get 1,000 requests per second and measure the latency that I have for these 1,000 requests per second. You have kind of two ways to try to do benchmarks. Is either I try to measure how many RPS I can get as maximum, right? And you have the way where you say I want to set the number of RPS I want to measure the latency, which is generally what people care more about when it is about service mesh. They want to know what will be the added latency when I have like some workloads running. And I run this test, which is basically saying I want to have 4 clients, 4 K6 clients that will send requests, and I limit the CPU and memory, but it's not even going to use all of this. And then I'm waiting for that to be finished, and I'm doing some annotation in Grafana. I don't know if you are familiar with that. It's pretty nice. You can say, I want to annotate Grafana to say, this is my starting point, my ending point, so it's very easy to read which test was running at which time, right? So now I should be able to port forward here to be able to access Grafana, and I will port forward here to access Kiali. So obviously, if I go to Kiali first, I will see that there should be nothing happening here because I am doing the baseline graph, right? So I don't have any metrics. I don't have a service mesh in place here, so I cannot see what's going on. But if I go to Grafana, so you see, it seems like it's a lot of variation, but as you can see, really, there is no variation because it's like between 168 microseconds or 170 microseconds, right? So when it's going to be to the other step, it's going to be like more like looking like a flat line, right? But this is like the baseline, and as I say, I try to reproduce what you get in these official numbers, and I think we are pretty close. So I think you have P90 and P99. So right now I'm doing P99 here. So on the P99, the baseline with the CPU they use is like 180. In my case, I think it's like 170. And I am sharing somewhere in the slide as well the CPU that I'm using. Like it's this AMD CPU that is 5 years old, so it's not even like the most powerful CPU you could get in like a proper server, right? So it's running this, and you see because of the annotation, now I see, okay, this was the baseline, and it started at that time, and it finished at that time. So it's going to be helping me to see the different numbers. So now you see it goes to the sidecar. So what happens behind the scene is just like before it starts the sidecar test. Oh no, it's not before. It's when you do the sidecar test here. You see, I am adding in the client. I say I want to be injected. So it's just making sure that the K6 is injected, and the target now is the in-mesh service. Before it was the not in-mesh service. Okay. So if I go to Kiali now, I see here that I am having the metrics here, and I have the L7 metrics because you can see my 4 runners, K6 runners, that are sending requests to this in-mesh service. I didn't show you that here, but if I would go to HTTP bin, you can see that I have like 4 not in mesh, 4 in mesh, 4 in ambient, right? Just trying to have like these 4 clients and 4 servers here. So when it continues, it kind of show me, okay, the cost of the sidecar, like now it's not like getting the baseline, it's kind of getting 750 or something like that. So the cost of my sidecar is like the difference, right, basically. So it's, let's say, a little bit less than 600 microseconds, right? So first of all, I want to demystify, right? A lot of benchmark you see, a lot of people sometimes do bashing on Istio because Istio is like the most popular one. So obviously, you see a lot of other solution that tries to pretend that Istio is not good and so on. First of all, I would say like how many applications really care about 600 microsecond latency. Obviously, if you have 10 microservices, chain one together, right? it would mean 6 milliseconds, and for some cases it matters, right? But I want to first say, okay, with Ambient we do even better, right? But honestly, like it's still already good, right? This sidecar cost is really not that high, right? So that was the second one, and you see this is what we call sidecars. The third one is going to be just trying to add some layer 7 manipulation on this sidecar communication. The value should be pretty similar. It should not change much. But basically what I do here is I just create this HTTP route to add a header, right? So it's a very simple layer 7 manipulation. But obviously, if I need to do it or if I don't need to do it, it's kind of the same cost to have the sidecar because the sidecar is there anyway and is going to process at layer 7 and generate all these layer 7 metrics and so on, right? So you don't really expect any difference here. Sometimes you can see a difference, but it's really also because of, again, if you are familiar with metrics, it's not like a point-in-time view of something. It depends on the data that you had in the seconds before and the minutes before and so on. And you see also it's a little bit annoying when you see this peak here because this peak of 2,000 requests doesn't exist. It's like it's always 1,000 requests. I think it's just because that's using I-rate, which is very confusing if you use that with high variation data. If you put rate instead, that should be flat, I assume. Yeah, so you see 1K. So we are really at 1K. At the beginning, I was very confused why I was having always this peak that doesn't really exist. So you see, it's like, it's a little bit more, but it's kind of mostly a hazard. It's not really because of the processing takes, more time. It's like here we are speaking about microseconds, right? Like measuring things in microseconds, what's the difference between like 10 microseconds here or 20 microseconds there, right? If you run the test like 10 times, sometimes you will get 760, sometimes 780, or But basically, the long story short is having, as soon as you use sidecars, the layer 7 is available. If you start to use like basic features of layer 7, it's not going to really change much your performance. So what I'm going to do next is the ambient, right? So in that case, so this was the layer 7, then it was the layer 7 with, no, this is the ambient here. So you see what I changed is I enabled the ambient mode in the K6 namespace directly. I could have done that here for consistency. I just didn't think about it. But basically, it's going to be the same test, but in that case with just only layer 4. And if we go back to Kiali, you can see now, like because I only look at the last minute, you can see everything is blue because I have only TCP metrics right now. Okay, so it's just like the ambient part, and the latency added is very low, right? So if you only want like mutual TLS and a layer 4 observability, which is what people need first, right? Then you want layer 7 for some application. Some customers need layer 7 everywhere, which is fine. You can use Waypoint. But I would say from my experience, generally people use like the layer 7 capabilities for 30% or something like that. Like 70% of the cases are generally mutual TLS and basic layer 4 observability. So that means that you can get that with a very, very low cost, right? Like, I mean, like, what is the cost of this? Is like 338, 169, like maybe 150 microseconds, right? Added by your mesh and getting everything, encrypted and so on. Because I didn't show you, but it's like, just to make sure it is clear. So this is like, I have 3 nodes, and I did like an affinity rule so that if I go to K6, you will see that they are having their own worker here that is called kind1 worker. And everything that is in the other namespace is on the other worker. So yeah, just to see it's clear, right? So basically just showing you that everything goes from one node to another. It's not the same Z tunnel in the same node. It's like the cost that you see here is the cost of 2 ztunnel, right? It's like the source and the target and the mutual TLS in the middle and so on. So I think it's pretty impressive, right? It's like, compared to the benefits you get, you have like a very, very low overhead. And finally, what I do here is like, I want layer 7, right? So I need a waypoint. So the way you do that is by, first of all, deploying a waypoint. So here I deploy this waypoint, so I have like only 2 pods. Again, I didn't do 4 because there is no point to do that. I just put 2 just because that would be like the standard deployment pattern. You want high availability, so you don't want only 1. 2 is probably a good choice most of the time. So with less resources, right, I'm able to get like this layer 7 in place. I label the service in Ambient to say that I want to use this waypoint that I have deployed. And I apply the same HTTP route that I did in the sidecar with layer 7 manipulation, right, which is basically just adding a header. And if you want, what we can do at the end, we can replace the backend that is for tier by the standard HTTP bean backend, and we can just take a look at it and just make sure that we see this, happening. But we can also trust Kiali, and you see now that I have this green arrows, so I have this, layer 7 observability that is now available, and you can see here what is the cost of that. You see, like it's like around, you are a little bit less than 700 microseconds, so it's still a little bit faster than sidecars, but not so much, right? It's not a big difference. And it's kind of, again, on par with what you see in the official numbers, right? Like sidecars is the orange line, and Ambient with layer 7 is a little bit faster, right? But obviously, the reason why people would migrate from sidecars to Ambient is not because they want to get this small difference, right? Like the reason why people migrate is because you have a lot less resources used, right? You divide the resource used by a lot, depending on the use cases. So the cost is one of the big motivation. And the second motivation is really the operational cost, right? Because obviously, as soon as you go into this ambient mode, you can upgrade your Istio without even talking with the application teams, right? Like you can upgrade your ztunnel and your control plane, everything. You can even upgrade the waypoint because the waypoint is not inside the pods of the application, so you don't have to talk with the application team to do that, right? So that's the beauty of it. So that's the kind of the result of this benchmark. As I say, I can also show you quickly here. I could go to the HTTP bean. What I would do probably would be even faster. Let me go there. I think it's finished here. Yeah. So I could just here replace that service with the one I have initially. So let me go back to the in ambient. This is in mesh. In mesh, not in mesh. No, it's maybe the other one here. Yeah. So if I take that back with the original deployment and service, so I'll probably need to wait for a second. No, yeah. Wait for a second to do it. Oh, I think I delete everything at the end. Anyway, I'm not going to spend time on that. So yeah, you have the result here. As I said, this is the environment I am using. I put the RAM here, but honestly, nobody cares. Really, what's important is the CPU. Like it's a 5-year-old CPU. If you use like the newest and newest CPU, maybe you can get even better latency. But I think the long story short is really that you get really pretty decent latency with the mesh. With layer 4, it's probably not even noticeable, right? The difference. If you have a mesh or not a mesh, if you have no ambient or if you have ambient layer 4, probably it's nearly impossible to notice the difference. If you have layer 7 and it's just like one microservice that you access, directly, again, I think it's probably not noticeable because adding like 500 milliseconds of latency is like nothing for most of the applications. Now, if you have like 10 applications chain one with another, then yeah, you could notice it, and obviously the smaller the better, and you can just put the layer 7 when you need it and not for any workloads. So these are the results that we've been looking at together. These are the instructions, so if you want to replicate it, because the idea was obviously to get your trust, right? So you can see the instruction and play with them. But the idea was also, okay, if tomorrow you want to test with your own environment, if you are using, like, as I say, if you are using EKS or GKE or AKS or whichever provider, right? Obviously, the baseline is not going to be the same few hundred of microseconds, right? It's going to be maybe 1 millisecond, the baseline, and maybe when you add the mesh, it will become 1.5 or 2 or whatever, right? So you can easily replicate that. So this is the link also for the Istio scalability page, and there is also this nice blog in Istio that was done by my colleague John, which is pretty nice when you want to understand also throughput, right? Because I really focused on latency because this is what people always seem to care about, right? Everyone comes to us and say, we want to have the lowest latency possible. But there are also cases where throughput is very important, right? So it happens. And John did really good work on that to show how fast Istio is also on this throughput that you can achieve. And there are also a lot of other blogs about like the scalability of the control plane and so on that I'm not covering here today. So that's it. I don't know if anyone has any question. Thank you.